Okay, see Lindelof videos, solving logarithmic equations, the essentials. You can do this on the TI-Nspire or TI-Nspire CAS. If you use the CAS, you do get some extra functionality, and I'll show you how that works. But let's just start to work on this. So this is all I'm going to do. I always start at my home screen. Right, I'm going to toggle through, up or down, toggle through. Very rarely do you want to use scratch pads, so I really suggest you stay out of it. And if you ever want to talk about that, we can. But you can see I'm on the calculator section. I'm just going to hit enter. From here, I know I'm going to use this solve function, and there are two ways to do it. You can just type in the word solve, S-O-L-V-E, open parentheses, and go from there. However, if you would rather, you can just go right here. I'm already on solve, but just want to tell you that if you go to the first choice, A through Z, type in the first letter of the word that you're looking for, it will pull it up for you. So I am going to solve. And then here's my equation that the first one I'm going to solve. I'm only using common logs right now, so I don't have to waste too much time. So if you want to use a common log, when you get to the base here, just don't put anything in, and it will automatically assume that you mean the common log. So the one I want is 2x plus 4 is my argument. So you can see everything is inside the parentheses, so it's inside the argument. And I want to set that equal to 3. So equals 3, and then remember you just put comma x, and it says what you want to solve in terms of. So if you had log of 2m plus 4 equals 3, and you wanted to solve in terms of m, you'd have to put an m here. So make sure this variable matches the inside variable. And here's the hard part where you hit enter, and there is your number. It actually does make sense how this works, right? Because you take 10 to the third power is 1,000. You then subtract 4 from both sides, and you'd get 996, and then you divide both sides by 2 to get 498. So, this is what I want to say to you. If you had a CAS, though, and you got back some weird answer, you could, let's change this just a tiny bit. Let's change this a tiny bit. So let's just do this. I'm going to pick this whole thing. I'm going to hit enter. Right? And what if you said you wanted to equal 2 instead of 3? So let's see if that would do it. 2, see if that makes a messier answer. Right? And I hit enter here. Damn. I'm going to try it just one last time because I want you to see this. To equal 7. Equals 7. See what you get here. All right. This is not. I guess what I'm telling you is if the number didn't work out perfectly, if it was going to be whatever, 4.9993678, etc., what it would give you instead is ln of something. It would give it back to you in symbolic language. And if you didn't like the symbolic language, you could just hit control equal sign, and it would convert it to a number. But it's really cool on tests where the professor gives you back answers in symbolic language. ln of 3. You're like, shit, what's ln of 3? Well, ln of 3 is ln of 3, and if the answer to any of these problems had been ln of 3, it would have given you ln of 3. And if you didn't like that, you could have hit control enter, and it would have given you 1 point whatever the number would be. So it's really cool the way what the CAS will do. Let's do 2 more problems so you can see how this does get a little bit dicey, and you have to pay a little bit of attention here. I'm going to go to solve again. In this case, though, I want log, so I want log. Here I have 4x, but check this out. So I want 4x here. But it said 4x minus 3, but there were no parentheses. So if you don't see parentheses, you have to assume that only what's directly attached to multiplication or division to the variable is the argument. So this one had minus 3. This is much different, much different than log of 4x minus 3. This is log of the quantity 4x minus 3. And it was set equal in our problem to 2. And hopefully you can see why this is different, because in this case what would happen is you would add, before you did anything, you would add 3 to both sides, and you'd get log of 4x is equal to 5. So this answer is going to get much bigger. So everything else is the same, right? And there's our answer. Again, look, if I did it this way, let me just show you this because it's actually really cool. If I took this 3 out of here, and I put the minus 3 in here, minus 3, that's a totally different answer, isn't it? This answer and this answer are nowhere near the same because these problems are not the same. So be very, very careful where your argument parentheses are. And if you don't see argument parentheses, assume that there are none and only put it with the variable. Okay? Let's do one last problem really quick, and you can hopefully practice this on your own. So I'm going to do the same thing. This time I'm going to type in the word solve so you can just see it. SOLV. See, it's all in parentheses. It's all in, what's that called when it's slanted? That thing. But when it recognizes a function that it knows, it puts it in standard print. Oh, it was in italics. Puts it in standard print. Then you can open it and put in control log. And in this case, I want 2x minus 8. So 2x minus 8 is equal to, and I want it to be equal to 2. So equal to 2, comma, x, hit enter, and there's your answer. So this is actually really, really cool. It will also check domain values for you. So if it comes up that somehow to make this happen, you'd have to have a negative here, it will give you a domain problem. If it does anything that turns your argument to a negative number, it will say false, and then it will tell you that you have a domain issue. So I hope this is helpful, and I feel like I dragged it on a little bit, but this thing is just so cool. You can get so much done with it. If you figure out anything cool that I haven't talked about and you want to talk to me about it, I would really appreciate it. So appreciate your comments. If you haven't already subscribed, please do.